You ever lay there staring at the ceiling, just wishing you could fall asleep?
Oh, yeah?
Well, imagine if your job depended on you being totally alert and rested. But insomnia was something you were battling all the time.
Yeah, that'd be rough.
And that is the reality for a lot of folks in the military.
Right.
Our deep dive today is actually inspired by some pretty cutting-edge research.
Okay.
They found that 85%
Wow.
of military personnel experience some kind of sleep disorder.
85%.
And a full 25% struggle specifically with insomnia.
That's a huge number.
Yeah.
Wow.
And we're going to explore today a brand new approach to dealing with this problem
Okay.
that doesn't involve medication.
Interesting.
And get this, it uses brain stimulation.
Brain stimulation, huh?
Yeah.
Well, it's definitely a big deal. Sleep deprivation has a massive impact on military readiness.
Right. It's not just about feeling tired.
No, not at all.
It's about, like you said, mission success and safety of the troops.
Absolutely.
Okay, so let's unpack this a little.
Sure.
What is going on with this brain stimulation idea?
So the research targets a specific brain network called the default mode network.
The what?
Default mode network, or DMN.
DMN. Okay.
And this is the part of your brain that's active when you're kind of lost in thought, daydreaming or dwelling on things.
So it's like that monkey mind that's always chattering away when I'm trying to sleep.
Exactly. And studies have shown that this DMN can become overactive in people with insomnia.
Oh, so that makes it even harder to quiet those thoughts and fall asleep.
Exactly.
Okay, so that's the problem. How does brain stimulation fix it?
So they're using a technique called transcranial magnetic stimulation.
Transcranial magnetic.
Or TMS.
TMS, okay.
It's a safe, non-invasive technique that's actually already being used for other conditions.
Okay.
It involves using this handheld device that delivers magnetic pulses to specific areas of the brain.
Hold on, are we talking like brain zapping here?
Well, it might sound kind of futuristic,
It does.
but it's actually a very precise and controlled method. And in this case, they're using a specific type of TMS called continuous theta burst stimulation.
Continuous theta burst.
Or CTBS.
CTBS, okay, got it.
It basically sends rapid quieting signals to that overactive DMN.
Okay, I need a visual here. I'm still picturing magnets and sleep.
Okay, so imagine the DMN as a noisy room full of people all talking at once.
Okay.
And those are your racing thoughts, right?
I gotcha.
CTBS is like gently hushing everyone in the room so you can finally hear yourself think they fall asleep.
So you're turning down the volume on the brain chatter.
Exactly.
Interesting. And that actually helps people fall asleep.
That's the idea. And what's really interesting is that initial studies showed sleep improvements after just one session of CTBS.
One session, really?
Yeah, just one.
Wow, so why even do a bigger study then?
Well, as remarkable as that is, we need more data.
Okay.
So they're launching a larger study with 120 participants
Okay.
to see if these short-term improvements can be sustained with multiple CTBS sessions.
So are they testing if this could be like a long-term solution?
Exactly.
Wow.
They'll be monitoring sleep using trackers and brainwave analysis
Oh, wow.
to see how different areas of the brain are actually responding to the treatments.
So it's not just about zapping the DMN, but figuring out like the best way to do it.
Precisely.
Like fine-tuning the settings.
Exactly. They want to determine the best placement for the device, the frequency of the pulses, and the ideal length of the treatment.
Wow, this is really fascinating stuff.
It is.
But this research is mainly focused on military personnel.
Right.
How likely is it that these findings will actually help the average person who has insomnia?
Well, the research is targeted at the high rates of insomnia in the military.
Yeah.
But the implications go way beyond that.
Okay.
Because the underlying mechanisms of insomnia are the same, whether you're in the military or not.
So the same brain networks are at play.
Exactly. So if this treatment proves safe and effective for military personnel, there's really no reason it couldn't be adapted and applied to the general population.
So we're talking about a potential drug-free solution that targets the root cause of sleeplessness.
That's the potential we're talking about.
That is pretty mind-blowing.
It is.
This is all from just one research article, right?
Well, this research is a big step forward in a much larger field of study.
Okay.
What's really interesting is that it aligns perfectly with some of the key priorities outlined by Congress,
Okay.
addressing mental health in the military and developing new non-drug treatments.
So it's hitting all the right notes scientifically and politically.
Absolutely. It's generating a lot of buzz.
Yeah. I can see why.
Yeah.
But before we get ahead of ourselves and start dreaming of brain zapping our way to perfect sleep,
Right.
we do need to emphasize that this is still ongoing research.
Absolutely.
Yeah.
It paints a very intriguing picture of what might be possible in the future of sleep science.
It really does.
And it goes even deeper than that.
Okay.
This research represents a shift towards more targeted and personalized approaches to treating sleep disorders.
So we're moving away from one-size-fits-all solutions, and we're starting to really zero in on the brain to find more precise and effective treatments.
Exactly.
Wow.
And as we continue to unravel the mysteries of the brain, who knows what other groundbreaking discoveries await us?
Maybe we'll find ways to not only treat sleep disorders, but to actually enhance sleep quality and unlock the full potential of our minds.
That's a great thought.
Now that's a thought to sleep on.
Yeah.
But before we get too deep into those possibilities, let's shift gears and really delve into the specifics of this new study.
Okay, sounds good.
What are they hoping to learn? How will they measure the results? And what are the potential benefits and challenges of this approach?
Great questions. Let's dive into that right after.
We figure out how to quiet down our own DMNs. Like we're feeling a nap coming on already.
I think we all could use a good nap sometimes. We'll be back in a moment.
So before the break, we were talking all about brain stimulation to treat insomnia.
We were.
And I, for one, am very curious to hear more about the larger study they're launching.
Okay.
Can you tell us more about what they're actually planning on doing?
Sure. So they're going to be working with 120 participants,
Okay.
all of whom struggle with insomnia.
Gotcha.
And over 2 weeks, they'll each get 10 sessions of continuous theta burst stimulation.
So more sessions than the initial study and over a longer time?
Right.
What's the reason for that?
Well, the researchers are hoping to see if those improvements we talked about can be sustained over time
Okay.
with repeated exposure to the CTBS.
So they want to see if they can make it last longer.
Exactly.
Okay, that makes sense. But how will they measure the improvements?
Okay.
Are they just asking people how they slept?
They're actually using a few different methods.
Okay.
First, participants will be using sleep trackers.
Okay. Yeah, those things everybody's wearing these days.
Exactly. And this will give the researchers objective data on sleep duration, wakefulness, and sleep stages.
Concrete data from the trackers, but are they going even further than that?
Oh, yeah, they are.
Okay.
Participants are also going to be using portable brainwave monitors.
Wait, are we talking about those EEG caps you see in movies?
Sort of, but much more user-friendly.
Okay.
These devices let the researchers actually track brain activity during sleep.
Wow.
This gives them a lot of insight into something called sleep architecture.
Sleep architecture.
Yeah, and how it's affected by the CTBS.
And what does sleep architecture even mean?
So think of it as the different stages of sleep that you go through at night,
Okay.
like light sleep, deep sleep, REM sleep.
Gotcha.
And by analyzing those brain waves, the researchers can actually see how the CTBS is impacting each stage.
So it's not just about how long they're sleeping,
Right.
but the quality of the sleep as well.
Exactly. And when they combine the tracker data with the brainwave analysis, they get a much more complete picture.
Wow, very thorough.
Yeah.
So with all this data, what are they hoping to find?
Well, they have a few main goals.
Okay.
First, like we said, they want to see if those short-term benefits last.
Okay.
And second, they want to really fine-tune the technique. They'll be studying how different areas of the brain respond.
So figuring out the most effective way to stimulate the DMN.
Right. They're essentially trying to find the sweet spot.
Find the sweet spot. Okay, I like that.
Yeah. So they'll be looking at the placement of the device, the frequency of those pulses, and the length of the treatment.
Wow.
It's all about maximizing the good and minimizing any potential downsides.
This is really promising and sounds like it could help so many people.
It does.
But no scientific breakthrough comes without its challenges, right?
You're absolutely right.
What are some of the limitations they might run into?
Well, even though TMS is considered really safe, it's important to remember that some people do have side effects.
Like headaches or tingling?
Exactly. And while those are usually temporary, it's still something to consider.
Of course.
And then there's also the issue of cost.
Yeah, I bet this kind of technology isn't cheap.
You're right, the devices are expensive, and you need specially trained people to use them.
Okay.
So even if it works, making it available and affordable to everyone could be tough.
So some logistical hurdles for sure.
Yeah. But even with that, the potential benefits are huge.
They really are.
If it leads to a safe, effective, and drug-free treatment, that would be huge.
It really would be.
Both for the military and everyone else.
Definitely something to watch.
Definitely.
You know, it's fascinating how this research represents a shift in how we're thinking about sleep disorders.
Mm-hmm.
We're moving away from those one-size-fits-all approaches.
Yeah.
And we're zeroing in on the complexities of the brain.
Absolutely. We're finding more precise and effective ways to treat things.
Wow. And as we learn more about the brain, who knows what else we'll discover?
Exactly. There could be even more groundbreaking stuff on the horizon.
Maybe we'll even be able to boost sleep quality and unlock even more of our brain power.
Wouldn't that be something?
I'm getting ahead of myself again.
It's exciting stuff.
It really is hard not to get excited thinking about the future of sleep science.
It is.
This has been a truly fascinating deep dive,
It has.
and I feel very inspired.
Me too. And this research is really just the tip of the iceberg when it comes to sleep.
Yeah, so much more to learn.
Exactly.
So we dove deep into the potential of this new insomnia treatment, but obviously it's not all going to be easy.
Right.
What are some of the bumps in the road we might see?
Well, one thing is, even though TMS is generally considered safe, some folks might have side effects,
Okay, like what?
headaches, or
Yeah.
tingling sensations.
Right. I've heard about that.
And usually it's temporary and nothing serious,
Sure.
but still something to consider.
Yeah, of course.
And then there's the cost issue.
Yeah, I was thinking about that.
I mean, this is cutting-edge stuff. It's not going to be cheap.
No, probably not.
The devices themselves are expensive, and then you need people trained to use them.
Right.
So even if the research shows it really works, getting it to everyone will be a challenge.
Yeah, some hurdles to overcome, for sure.
For sure.
But even with all that, the potential benefits are huge.
Totally agree. I mean, if this can give us a safe, effective, and drug-free insomnia treatment, that would be revolutionary
Revolutionary, yeah.
for the military and everyone else.
So much to watch here.
Absolutely.
You know, it's really fascinating how this research is changing how we think about sleep disorders.
Uh-huh.
It feels like we're moving away from one-size-fits-all solutions
Yeah,
and really starting to dig into how the brain works.
exactly. We're getting so much more precise with treatments.
And as we learn more, who knows what we'll find.
Right? There could be even bigger discoveries out there.
Imagine being able to not just treat sleep disorders, but actually improve sleep quality
Wow.
and unlock even more of our brain's potential.
No, that would be something.
Getting a little ahead of ourselves.
A bit, yeah. But it's exciting to think about.
It is. It's hard not to be excited about the future of sleep science after a deep dive like this.
For sure.
And I think it's important to remember this research is just the beginning.
Yeah, the tip of the iceberg.
There's so much more to learn about sleep.
So much.
Well, on that note, I think it's time to wrap up this deep dive. But before we go, I want to leave you with this thought.
Okay.
What we've talked about today is truly groundbreaking stuff.
It is.
It could really change the lives of people struggling with insomnia.
Absolutely. And it highlights how important sleep is.
Yeah, it's not just about feeling rested.
No, it's about our minds, our
Yeah.
emotions, our physical health.
So if you're out there struggling to get a good night's sleep,
Mm-hmm.
know that there's hope on the horizon.
Definitely.
Maybe someday we'll all have little brain zappers helping us sleep.
Maybe so.
But until then, keep finding ways to prioritize your sleep.
Good advice.
And stay tuned, because there's much more to come in this field.
Lots more to discover.
Thanks for joining us on this deep dive into brain stimulation and insomnia.
It was my pleasure.
Until next time, sleep well.